Hello, welcome back. I'm John, old YouTuber. Let's continue. It's Thursday today, and I did pay my bills today. And just made my budget for next month, October. It's 1st September day. Is September. It's 1st September. Just made my budget for next month, October. I should get some money back from my heating bill because I did close my heating in start of February. So that was a little bit cold. February, March was cold. A little bit April. I took all the heating off because I was afraid my heating bill should explode. Because we have this inflation and energy crisis and stuff. But let's close my door to the balcony. Yes, let's finish my project. Read about the memory. So I need all this SSD memory. I think I did finish this one, synchronous dynamic random. I think I did finish that. Yes. But I got off my bed not long time ago. Yes, cheers. So I did pay my bills today. I need to pay one more bill that's I'm waiting list for some social housing. Then you pay a fee every year. You pay a fee, but we have this inflation, so everything is raising. My internet broke. I had to try adjust. Yes, but let's just try to continue this. And speaker level 50, 54 or something like that. And I have to check my cell phone because I think got something there. I want to charge my cell phone, but I could hear something when I start recording. Yes, that was some Lego news. And I'm uploading a Danish video. I need to put public. I need my blankets. Yes, I need half a minute to do myself ready. So I just have to go through this month's one day by one day. Take one day. Today is Thursday. I'll not do anything today. I'm not going to buy more food or anything. So just go through this day and tomorrow and the weekends and to next week. So let's read this, and I don't understand a lot of stuff. I don't understand, but I like to read it anyway.
DDR SDRAM. DDR SDRAM double data rate synchronous dynamic random access memory desktop DDR memory comparison.svg. Comparison of DDR modules for desktop PCs. DIMM. 1 GB DDR1 400 MHz 8.jpg Front and back of a 1 GB DDR400 RAM module for desktop PCs. DIMM. Developer Samsung. 1, 2, 3. JEDEC tip synchronous dynamic random access memory generation SDRAM 2. DDR3. DDR4. DDR5. Release date DDR 1998. DDR2 2003. DDR3 2007. DDR4 2014. Double data rate synchronous dynamic random access memory (SDRAM) is a double data rate DDR synchronous dynamic random access memory (SDRAM) class of memory integrated circuits used in computers. SDRAM, also retroactively called DDR1 SDRAM, has been superseded by DDR2 SDRAM, DDR3 SDRAM, DDR4 SDRAM and DDR5 SDRAM. None of its successors are forward or backward compatible with DDR1 SDRAM, meaning DDR2, DDR3, DDR4 and DDR5 memory modules will not work in DDR1 equipped motherboards, and vice versa. Compared to single data rate, SDR, SDRAM, the DDR SDRAM interface makes higher transfer rates possible by more strict control of the timing of the electrical data and clock signals. Implementations often have to use schemas such as phase-locked loops and self-calibration to reach the required timing accuracy. 4, 5. The interface uses double pumping, transferring data on both the rising and falling edges of the clock signal, to double data bus bandwidth without a corresponding increase in clock frequency. One advantage of keeping the clock frequency down is that it reduces the signal integrity requirements on the circuit board connecting the memory to the controller. The name double data rate refers to the fact that a DDR SDRAM with a certain clock frequency achieves nearly twice the bandwidth of a SDR SDRAM running at the same clock frequency. Due to this double pumping. With data being transferred 64 bits at a time, DDR SDRAM gives a transfer rate, in bytes /s, of memory bus clock rate, 2, for dual rate, 64, number of bits transferred, /8, number of bits /byte. Thus, with a bus frequency of 100 MHz, DDR SDRAM gives a maximum transfer rate of 1600 MB /s. Contents. History. Specification modules. Chip characteristics. Double data rate, DDR, SDRAM specification. Organization. Generations mobile DDR. See also. References. External links. History. In the late 1980s, IBM had built DRAMs using a dual-edge clocking feature and presented their results in the International Solid-State Circuits Convention in 1990. 6, 7. DDR5, 2020. Specifications Voltagedra 2.5/2.6. DDR2 1.8. DDR3 1.5/1.35. DDR4 1.2/1.05. DDR5 1.1. A Samsung DDR SDRAM 64-bit chip. Samsung demonstrated the first DDR memory prototype in 1997. 1. ARM released the first commercial SDRAM chip, 64 MB, in June 1998. 8. 2. 3. Followed soon after by Hyundai Electronics, now SK Hynix, the same year. 9. The development of DDR began in 1996. Before its specification was finalized by JEDEC in June 2000, JEST 79.10. JEDEC has set standards for data rates of DDR SDRAM, divided into two parts. The first specification is for memory chips, and the second is for memory modules. First retail PC motherboard using DDR SDRAM was released in August 2000. 11. Specification. Single generic DDR memory module for DDR RAM slots Corsair DDR400 memory with hair spreaders modules. To increase memory capacity and bandwidth, chips are combined on a module. For instance, the 64-bit data bus for DIMM requires 8 8-bit chips, addressed in parallel. Multiple chips with the common address lines are called a memory-rank. The term was introduced to avoid confusion with chip internal rows and banks. A memory module may bear more than one rank. The term sites will also be confusing because it incorrectly suggests the physical placement of chips on the module. All ranks are connected to the same memory bus, address and data. The chip select signal is used to issue commands to specific rank. Adding modules to the single memory bus creates additional electrical load on its drivers. To mitigate the resulting bus signaling rate drop and overcome the memory bottleneck, new chipsets employ the multi-channel architecture. Physical DDR layout comparison of memory modules for portable /mobile PCs, SDRAM. Comparison of DDR SDRAM standards name a kit bus dimmings voltage, V, standard type module clock rate, MHz, cycle time, NS, 12, clock rate, MHz, transfer it, mount /S, bandwidth, MB/S, CLTRCD to CAS latency, NS. DDR200 PC 16001010101020016002222202.5 plus or minus 0.2 DDR266 PC 21001337.5133266.6721332.5-3-318.75 DDR333 PC 27001666 6166333266662.53315 DDR400 EPC 320020005200320002.5-3-312.52.6 plus or minus 0.1 B33315 C34415. Note: all above listed are specified by JEDEC as JEST 79F.13. All RAM data rates in between or above these listed specifications are not standardized by JEDEC. Often they are simply manufacturer optimizations using tighter tolerance or overvolted chips. The package sizes in which DDR SDRAM is manufactured are also standardized by JEDEC. There is no architectural difference between DDR SDRAM modules. Modules are instead designed to run at different clock frequencies. For example, a PC 1600 module is designed to run at 100 MHz, and a PC 2100 is designed to run at 133 MHz. A module's clock speed designates the data rate at which it is guaranteed to perform, hence it is guaranteed to run at lower, underclocking, and can possibly run at higher, overclocking, clock rates than those for which it was made. 14. DDR SDRAM modules for desktop computers, dual inline memory modules, DIMMs, have 184 pins, as opposed to 168 pins on SDRAM, or 240 pins on DDR2 SDRAM, and can be differentiated from SDRAM DIMMs by the number of notches. DDR SDRAM has 1, SDRAM has 2. DDR SDRAM for notebook computers, SODIMMs, have 200 pins, which is the same number of pins as DDR2 SODIMMs. These two specifications are notched very similarly and care must be taken during insertion if unsure of a correct match. Most DDR SDRAM operates at a voltage of 2.5 V compared to 3.3 V for SDRAM. This can significantly reduce power consumption. Chips and modules with DDR400 /PC 3200 standard have a nominal voltage of 2.6 V. JEDEC standard number 21C defines three possible operating voltages for 184-pin DDR, as identified by the key notch position relative to its centerline. Page 4.5.10-7 defines 2.5 V, left, 1.8 V, center, TBD, right, while page 4.20.540 nominates 3.3 V for the right notch position. The orientation of the module for determining the key notch position is with 52 contact positions to the left and 40 contact positions to the right. Increasing operating voltage slightly can increase maximum speed, at the cost of higher power dissipation and heating and at the risk of malfunctioning or damage. Capacity number of DRAM devices. The number of chips is a multiple of 8 for non-ECC modules and a multiple of 9 for ECC modules. Chips can occupy one side, single-sided, or both sides, dual-sided, of the module. The maximal number of chips per DDR module is 36, 9 for ECC and 32, 8x4, for non-ECC. ECC vs non-EC modules that have error-correcting code are labeled as ECC. Modules without error-correcting code relabeled non-ECC. Timing CAS latency, CL, clock, number of DRAM devices. This example compares different real-world server memory modules with the comments.
Yes, did click by mistake, because I'm sleepy always, so we have to read page by page.
Run at lower, underclocking, and can possibly run at higher, overclocking, clock rates than those for which it was made. 14. DDR's DRAM modules for desktop computers, dual inline memory modules, DIMMs, have 184 pins, as opposed to 168 pins on SDRAM, or 240 pins on DDR2 SDRAM, and can be differentiated from SDRAM DIMMs by the number of notches. DDR SDRAM has 1, SDRAM has 2. DDR SDRAM for notebook computers, SODIMMs, have 200 pins, which is the same number of pins as DDR2 SODIMMs. These two specifications are notched very similarly and care must be taken during insertion if unsure of a correct match. Most DDR SDRAM operates at a voltage of 2.5 V compared to 3.3 V for SDRAM. This can significantly reduce power consumption. Chips and modules with DDR400 /PC 3200 standard have a nominal voltage of 2.6 V. JEDEC standard number 21C defines three possible operating voltages for 184-pin DDR, as identified by the key notch position relative to its centerline. Page 4.5.10-7 defines 2.5 V, left, 1.8 V, center, TBD, right, while page 4.20.540 nominates 3.3 V for the right notch position. The orientation of the module for determining the key notch position is with 52 contact positions to the left and 40 contact positions to the right. Increasing operating voltage slightly can increase maximum speed, at the cost of higher power dissipation and heating and at the risk of malfunctioning or damage. Capacity number of DRAM devices. The number of chips is a multiple of 8 for non-ECC modules and a multiple of 9 for ECC modules. Chips can occupy one side, single-sided, or both sides, dual-sided, of the module. The maximal number of chips per DDR module is 36, 9 for ECC and 32, 8x4, for non-ECC. ECC vs non-EC modules that have error-correcting code are labeled as ECC. Modules without error-correcting code relabeled non-ECC. Timing CAS latency, CL, clock cycle time, TCK, row cycle time, TRC, refresh row cycle time, TRFC, row active time, TRAS, dot buffering registered, or buffered, VS unbuffered. Dot packaging typically DIM or SO-DIM. Dot power consumption. A test with DDR and DDR2 RAM in 2005 found that average power consumption appeared to be off order of 13 W per 512 megabytes module. This increases with clock rate and when in use rather than idling. 15. A manufacturer has